Okay, so in this question, being concise in terms of how the question is presented, a librarian is interested in 3 different types of training, and they have 16 participants in each type of training. And the question is, can you fill in the remainder of the ANOVA summary table? We're given the mean square between and the sum of squares total. The first thing to do is that we need to get the degrees of freedom. Once we get the degrees of freedom, we can calculate the sum of squares using the mean square and get this other sum of squares and finish it up. So the degrees of freedom between is the number of groups we have minus 1. We have 3 types of training, so we have 3 groups minus 1. So we have 2 degrees of freedom between. And while we're at it, we're going to finish up these degrees of freedom. The degrees of freedom total is big N minus 1. We have 16 per group, but we have 3 groups. So we need to multiply 16 times 3, and that is 48. That's the number of participants. That's big N. So then our degrees of freedom total is 48 minus 1, so it's 47. And then we can calculate the degrees of freedom within either by taking degrees of freedom total minus degrees of freedom between, or we can do big N minus K. Big N was 48 minus 3, which is 45. We still need to figure out, so these are the ones that we've figured out so far, right here. And now what we can do is we can find the sum of squares between, because the mean square is equal to sum of squares divided by degrees of freedom. So then if we multiply both sides by degrees of freedom, these two cancel out, and we have sum of squares equals mean square times degrees of freedom. The mean square was 21 multiplied by 2. So the sum of squares between is 42. Now that we have 2 of the sum of squares, we can calculate the other. Sum of squares total equals sum of squares within plus sum of squares between, which means if we subtract sum of squares between from each side, we get sum of squares within equals sum of squares total, subtract sum of squares between. Sum of squares total was given to us, it's 312. Subtract 42. Is 318. Nope, there's no way that is. 312. Subtract 42 is 270. Notice how I'm putting in my values as soon as I calculate them, because otherwise there's a lot of numbers and it's hard to keep track of them all. Before we can calculate our F, we need our mean square within. And so that is going to be sum of squares divided by degrees of freedom. So 270 divided by 45. Just 6. Then I can calculate my F statistic, which is mean square between divided by mean square within. 21 divided by 6. Just 3.5. And then what I would need to do is I would compare this value to my critical value. And the critical value, the degrees of freedom I would use are 2. In the numerator, it was 2. And in the denominator, the degrees of freedom was 45. And then I would look that up in table B4 and find that critical value. And if the value I calculated is larger than my critical value, then I reject the null and accept the alternate hypothesis.